Greetings, this is Parameshwaran pursuing my final year master's degree in chemistry specialization, and now we are going to see about an important concept in NMR spectroscopy that deals in the analysis of chemicals. So now, nuclear Overhauser effect. This is the title. So, nuclear Overhauser effect is a phenomenon in which the signal of a proton is affected if another proton is irradiated with a radiation, that is induced radiation. So let us consider that we are irradiating a nucleus, that is a proton. So this irradiation will affect the neighboring proton atom too. So this is called as nuclear Overhauser effect, that is NOE effect. Nuclear Overhauser effect can also be called as nuclear Overhauser effect spectroscopy, that is NOSE. So, nuclear Overhauser effect affects the neighboring proton that is nearby or closer to each other. So, there is a condition for this. So, what is the condition? Let us see. When a proton is irradiated with a radiation, its neighboring proton peak gets affected. That the distance between the two proton, that is the two hydrogen, should be 5 to 6 Armstrong unit. So the distance must be 5 to 6 Armstrong unit. So this is compulsory in case of nuclear Overhauser effect to be performed or analyzed or observed. So this effect arises due to dipolar interaction between the two protons in the space. So two protons are arranged in a space that their dipolar interaction attracts each other, and nuclear Overhauser effect can be observed. So this method is used to determine the proximity of the spin, whether the spin upward or the spin downward, or either the two spins of the proximity, and the distance between the two protons, how much far the protons are located between each other. So the distance between the proton can be analyzed using this nuclear Overhauser effect. So this nuclear Overhauser effect is a modern technique used in NMR spectroscopy, that is nuclear magnetic resonance spectroscopy. So let us consider how it is performed. So it is performed by irradiating, that is performed by induced radiation in a proton that will affect the intensity of the neighboring proton. So how it is performed? When we are irradiating or introducing a induced radiation to a proton, its neighboring proton will also get affected by its nuclear distances or proton internuclear distances. So the peak of the signal will be definitely affected when NOE is observed. So NOE can result in positive, negative and equilibrium signal upon irradiation. It depends on the size of the molecule. Okay, let me explain. So there is a 3 proton signals. So we are irradiating in the first proton. So this proton signal will change, and it will also affect the neighboring proton. If the neighboring proton signal gets increased, so that is positive nuclear Overhauser effect. If the neighboring proton signal gets decreased, that is negative nuclear Overhauser effect. So if there is no change in the peak, that remains the same as it is considered to be in equilibrium. So there is no change. So that is in equilibrium. So positive, negative and equilibrium. So in other words, it is a change in intensity of nucleus when the spin states of nucleus is perturbed. So this is a change in intensity of the nucleus when the other proton is irradiated or perturbed. So this phenomenon is NOE. Let us consider if a signal gets increased, this is positive nuclear overhauser effect. If the signal gets decreased, that is negative overhauser effect. If the signal gets no change and it remains constant, that is in equilibrium. So these factors should be used to study the nuclear overhauser effect and whether it is positive or negative. Then let us consider about the what are the outcomes of this effect. So NOV effect occurs through the space interactions, spatial interactions that occurs within the molecule, and this occurs due to the dipole-dipole interactions. This is used to determine what is the application of NOE. NOE is used to determine the inter and intranuclear distances, that is inter and intramolecular distances. By performing NOE, you can identify the distance between the two protons, that can be inter within different molecules or intra within a molecule. Okay, this NMR technique, that is NOE, is used to analyze the 3D structures of an organic molecule or organic compounds, and it is also used to analyze various types of organic molecules and their stereotypes, whether it is dextro or levo. Okay, and this is very important tool to study stereochemistry and in pharmaceutical industries. So this is an evolving technique in science, and also this technique is used to study the structure of proteins, that is protein molecules. The protein molecule is a very complicated molecule, and its structure can be easily studied using nuclear overhauser effect by performing nuclear overhauser effect spectroscopy in NMR spectroscopy. Okay, then let us see what is relaxation effect. So if the nuclear overhauser effect arises, we are supposed to see what is relaxation effect. So relaxation is a process of bulk magnetization. Okay, when the peaks get too excited, so when you are supplying a irradiation in a proton, the molecule gets excited so soon. So this excitation should be returned back to ground state. So when you are performing a relaxation, when you are performing a irradiation, obviously after cutting the short pulse of radiation, that is intense short pulse of radiation, the excited molecule will definitely comes down and relaxes back. So this relaxation can be brought through by magnetization, that is bulk magnetization. So nuclear spins act as a tiny magnet. So these tiny magnets interact with each other and produces magnetic field around the spin. So this creates a change in the magnitude and orientation due to some thermal motions within the molecule. That may be molecular rotation or molecular collision or any other fluctuations observed in the molecule. So this is can be classified into spin lattice relaxation and spin relaxation. The type of the relaxation can be defined as spin lattice and spin relaxation. So let us consider why this is performed. The net absorption can only be restored The net absorption can only be restored if the nuclear relaxes back to the lower state. When it is absorbing radiation, the absorbed power will get increased. So the total absorbed power can be only analyzed when it is relaxes back. So we are finding simply that how much amount of radiation is absorbed by the molecule by calculating the distance between the excited nuclear and the ground state nuclear. So this is relaxation effect, that is relaxation process. So these are evolving NMR techniques that are found to be in uh, current spectroscopic techniques. And let me conclude with this. Thank you guys.